In this video, we're going to show you how to build your own DAO inspired by Compound. Now, this is going to be 100% on-chain voting and on-chain governance. We're going to show you the easiest way to spin up an NFT or an ERC20 voting type DAO, all using Solidity and Hardhat. Now, if you haven't watched my last video going over the architecture of DAOs and what goes into one of these, be absolutely sure to watch that video first and then come to this video, because that video explains all the philosophy behind what we're doing here. We're going to be using Openzeppelin contracts and the Hardhat framework to build this all in Solidity. If you want to see a Brownie or a Pythonic version of doing this, check the link in the description because we did a video over at the Chainlink Hackathon recently. And additionally, we know that because we're doing this 100% on-chain, gas fees are going to be expensive. So I'm really looking forward to somebody doing a Chainlink plus IPFS plus snapshot integration so that we can do all this off-chain. And once that exists, you already know I'm going to make a tutorial on that. And if you like this style of content, be sure to smash the like button, subscribe, and leave a comment in the comments section to let me know what you want to see next. Let me know how you want to supercharge your smart contract developer experience. So let's jump in.
All right, so here's what we're going to be building. We're going to have a very basic smart contract here, right? It's called box, and all it can do is store a value and then retrieve a value. But the thing is, it's ownable, and only the owner of this contract can call the store function. And guess who the owner is going to be? The owner is going to be the DAO. So only through a process of governance can anyone store a different function here. And once we're done, we're going to go through the entire process of proposing, voting, queuing, and then executing a transaction in a DAO to update our box contract. And that's one of the beautiful things about these DAO setups is that they're completely modular, right? And so when I go through the whole process, I'll do a hard-hat test here, which my tests right now are set up to just do everything. We're going to see every single step that this DAO is going to take. So we see box starting value is going to be 0. And then all of this stuff is going through the governance process. These are just some notes. Basically, people are voting, queuing, and executing. And then at the end, we change the value of the box contract through a voting process. And that's exactly what we're going to show you how to do today. Now, remember, all the code for what we're going to be doing here is in my DAO template GitHub repo. So if you ever get lost, feel free to refer back to this to get started. And additionally, if you want to see the Pythonic version of this, feel free to go back to the DAO mix. The main thing is, though, that all the contracts are going to be the same no matter what. Brownie, Hardhat, DAppTools, Foundry, it doesn't matter. So the first part of this section is going to be exactly the same. And here's our agenda here. First, we're going to write the smart contract. So if you're not familiar with Hardhat, who cares? We're going to be doing the smart contracts first. Then we are going to write deployment scripts. And this is where your Hardhat knowledge is going to come into play. We're going to be writing our deployment scripts in TypeScript here because TypeScript is phenomenal. If you're unfamiliar with TypeScript, I challenge you to rewrite this in JavaScript and make a JavaScript version. And then finally, we're going to write some scripts to interact with our governance, with our deployed contracts. Now, a quick note. This isn't how I originally built this. I didn't just write the smart contracts, write the deployment scripts, write the scripts, and then the tests, and boom, I was done. I had a back and forth between tests, smart contracts, deploy scripts, etc. If you're thinking, oh my goodness, that's so easy for him to go through this so seamlessly, when I originally wrote this code, it was a lot of back and forth, and that's how you should be developing. You're gonna be moving between tests and smart contracts and stuff. Additionally, in this tutorial, we are gonna show you some sick Hardhat skills. So you are not only going to learn how to build a DAO, but you're going to learn some really advanced Hardhat skills. So let's jump in. Let's do this. So the code editor I'm using is Visual Studio Code. So make sure you have a code editor up and ready to go. And you'll need a couple of prerequisites here. Again, the prerequisites are in the GitHub repository. We're going to need Git, Node.js, and Yarn. If you want to just clone this repo and follow the instructions here to get started, you absolutely 100% can. And then you don't even need to build this from scratch, but we're going to want to learn to build this from scratch. So let's just start git -- version. Great. We have git node -- version. Great. We have node and then yarn -- version. Great. We have yarn. We can get started. So everything that we're going to be installing here for packages is going to be a dev dependency. So the first thing we need to do is do yarn add -- dev Hardhat if you haven't already. And now in our folder, we're going to have node modules package.json, readme, and a lock, of course. So now that we have that, we can run yarn Hardhat. We're going to get the Hardhat CLI up, and we're going to have all this stuff in here. We're just going to create an empty hardhat.config.js, and we're going to turn it to TypeScript. The advanced sample TypeScript project has a bunch of stuff that I don't like. So we're just going to create an empty hardhat.config.js, and perfect. We've got a little hardhat.config.js. Now let's go ahead and create a folder, our contracts folder. And this is where we're going to add all of our contracts. So the first contract that we're going to need is the contracts we want to have govern, which in our case is going to be box.sol. Now I am actually just going to copy paste my box.sol here because it's not particularly interesting, but you could really code whatever you want here. So feel free to pause the video, copy paste from my GitHub repo, create your own governance contract that you want to play with, or do whatever you want here. But for us, we just have a store function and a retrieve function and an event, and then a private value that we're going to be storing and retrieving. And that's it. So of course, we want to fix this. We're importing from Openzeppelin contracts. Openzeppelin is amazing. But we're going to want to add this. So we'll do yarn add --dev at Openzeppelin contracts. And that should get rid of the box.sol. Let's reopen box.sol. And boom, looks like we did indeed get rid of that. Perfect. And for extensions, I'm using the Solidity, the Juan Blanco Solidity extension. That's why we get those wonderful linting things here. Great. So now we want to check to see if this compiles. If you're using Remix, you can compile with Remix. Hardhat, you're going to see how we compile here. Or if you're using, Brownie, we just want to see if this compiles correctly. So run yarn hardhat compile. Oh, it looks like we ran into some compilation errors because we need to update this. Let's use 8.8 of Solidity, and we'll try to compile again. And perfect. Looks like we're compiling successfully. Look here, we do indeed have our contract in here. Okay, perfect. Easy part out of the way already. That was so quick. Now, let's start creating the next part. Let's create the governance part. So what we're going to be working with to build this governance platform is we're going to be building it off of an ERC20 standard. So you're going to get an ERC20 token, and that's going to be the token that you get to vote. So let's create a new file called governance token.sol. Governance token.sol. And this is going to be the code for the token that we use to actually vote. Now we're going to create a normal ERC20 token, and then we're going to extend it to make it governanceable. And you'll understand what I mean in a second. So let's go ahead and make this SPDX license identifier. It's going to be MIT, Pragma Solidity. We'll do 0.8.8, and then we'll do contract governance token. And then we'll say is ERC20. I'm just going to go ahead and import Openzeppelin because Openzeppelin has a package where it basically has everything we need for an ERC20 token. So we're going to say import at Openzeppelin/contracts/token/ERC20. Actually, we can go to their GitHub. Openzeppelin contracts token ERC20, and we'll do ERC20.sol. We'll do this for now. Token ERC20.sol. We're going to change this, but don't worry about that yet. Now we're going to do a uint 256 public storage max supply. This isn't the best practice, but it's fine. We'll give this a max supply of this much, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1 million. We're going to do 1 million of these tokens. And then we're going to create the constructor ERC20. We'll give it governance token as a name. And then our symbol is going to be GT. And for those of you who don't know, when you inherit another contract, in your constructor, you can use that inherited contract's constructor as well. And in fact, I think you have to. So governance token GT, and then we'll even call one of these ERC20 functions called mint, and we'll mint to message.sender. So whoever deploys this ERC20 contract will just mint them everything, the whole max supply. Now, normally, if this was a normal ERC20 token, you'd be all done. But this isn't a normal ERC20 token. See, when we do votes, we need to make sure that it's fair. Imagine this for a second. Someone knows a hot proposal is coming up that they want to vote on. So they just buy a ton of tokens and then they dump it after the vote's over. We want to avoid this. We want to avoid people just buying and selling tokens to get in on governance. So what we do is we actually create a snapshot of how many tokens people have at a certain block. Snapshot of tokens people have at a certain block. And we want to make sure once a proposal goes through, we actually pick a snapshot from the past that we want to use. This kind of incentivizes people to not just jump in when there's a proposal and jump out, because once a proposal hits, it uses a block snapshot from the past. So we're actually going to need to change this a little bit. We're going to change this from an ERC20 to an ERC20 votes. And we can actually see this in Openzeppelin in the extensions /ERC20 votes.sol contract. If we go back to their GitHub, we can see ERC20 votes. They also have a snapshot, which is pretty similar. And some of the main functions are, it has these checkpoints. So these checkpoints are basically, hey, like, what is this snapshot? There's a number of checkpoints. You can also delegate your tokens to different people. So maybe you're not going to be available to actually vote. So you say, hey, I'm going to give my tokens to somebody else. You can get how many votes somebody has, past votes, get past totals apply. It has all these functions that make this token much better as a voting tool, right? Makes it much, much better. So we're going to say our contract governance token is ERC20 votes, and we just have to add an additional constructor, this ERC20 permit. Oops, sorry, I kind of copy pasted that. So ERC20 permit governance token. And great, now we have a governance token that is a little bit more capable of doing actual voting, right? Because it has these snapshot, it has this delegating functionality, it has these checkpoints. It's going to be much better for doing votes in a fair way. The only thing that we need to do though is we need to add some overrides, right? And we're just going to say the functions below are overrides required by Solidity. And this part's a little bit boring, so I am just going to copy paste it. Feel free to copy paste from my GitHub. But what we're doing is anytime we do this after token transfer, anytime we transfer a token, we want to make sure that we call the after token transfer of the ERC20 votes. And the reason that we do this is because we want to make sure that the snapshots are updated, right? We want to make sure that we know how many people have how many tokens at each block. Same thing with the mint. Same thing with burning. We want to make sure we always know how many tokens people have at different blocks, or excuse me, at different checkpoints, I should say. And that's the most important bit. At which checkpoint are you going to use for your token voting? So cool. Feel free to copy that again from my GitHub, or if you want, you could even just try the rest of the tutorial without this and see how you fare. But cool. So now we have a governance token, an ERC20 token that we can use for governance. So let's try to compile it. Yarn hardhat compile. All right, great. Looks like things are compiling successfully. Perfect. So our governance token looks good. Our box looks good. Let's actually now start creating our governance contracts. Now, we're actually going to make a folder called governance standard, because this is going to be the standard governance model. This is going to be this on-chain ERC20. And I plan on updating this in the future with, a governance off-chain or something, right? So for now, we're calling it governance standard because this is the quote unquote standard way to do governance. But in here, we're going to need two contracts, actually. We're going to need a governor contract.sol. And then we're also going to need a timelock.sol. And this will make sense in a second. So our governor contract.sol, this is going to be the contract that has all the voting code, all the voting logic that our governance token is going to use. The timelock is actually going to be an additional contract that is actually the owner. So the timelock and the governor contract are sort of one in the same, but the difference is the timelock is actually going to be the owner of the box contract. And this is important because whenever we propose or queue something to a proposal to go through, we want to wait, right? We want to wait for a new vote to be executed. Now, why do we want to do that? Let's say some proposal goes through that's bad. So like, let's say we have our box contract and then a proposal goes through that says everyone who holds the governance token has to pay 5 tokens or something like that, right? Or whatever, or who knows, right? Maybe that's something that you don't really want to be a part of. So all of these governance contracts give time. They give time to users to get out if they don't like a governance update. So we always want to have some type of time lock. So once a proposal passes, it won't go in effect right away. It'll have to wait some duration and then go in effect. So that's what the time lock is going to be for. Governor contract is going to have all of our actual code. Now we can cheat a little bit. Actually, we can cheat a little bit. So OpenZeppelin has this thing called the contracts wizard, and there will be a link to this in the description as well. And this OpenZeppelin wizard is a way for us to create really basic boilerplate code right in their wizard. So if we go to their wizard contract here, we can see we can make an ERC20, an NFT, 1155, and then finally this governor thing here. So we can give it a name. We're going to call ours governor contract. I'm going to explain what all this means. We can give it a voting delay, which is the delay since a proposal is created until voting starts. So once you create a proposal, you got to wait a little bit. The voting period, how long votes should go for. And the reason that this part here is important is because they actually do votes and voting period in terms of blocks. So it's an anti-pattern to actually do timed-based things in smart contract. It's much better to do block-based things. So we're saying 1 week, but that's going to be, you know, if the average block time is 13.2 seconds, we're going to figure out the week. Proposal threshold is going to be the minimum number of votes an account must have to create a proposal. So maybe you only want people who have a lot of your governance token to make votes. Quorum percentage, it's what percentage of people need to vote at all. So we're saying 4% of all token holders need to vote, or we could say, you know, exactly 100 tokens need to vote, whatever we want to do here. We also have some updatable settings. We have Bravo compatible. Bravo is the compound type contract. So if you want to make it integratable with compound, you can do that. Votes, comp like, or ERC20 votes. We're working with this ERC20 votes. We always want to do a time lock. We're going to do the Openzeppelin implementation of a time lock. You could also do a compound implementation. We aren't going to do upgradability here. However, I have a number of fantastic resources on how to actually do upgradability. And if we did want to do upgradability, it adds all this other stuff. We're not going to do that for now because it will make this a much longer video. And then you can add some stuff like this. But whew, so that's pretty much it. And I know this feels like you're cheating, but we're just going to copy this whole thing, right? Copy all that stuff that we put in. Copy to clipboard, and we're going to paste it in. Don't worry, I'm going to explain what's going on though. So we have our governor contract. And this is governor setting, governor counting simple, governor votes quorum frag, all this stuff. All these are just implementations to make it easier to be a governor. Governor counting simple is a way of counting votes. Governor votes is a way of integrating with that ERC20 contract. Quorum fraction is a way to understand quorum. Time lock obviously is time lock. This is going to be the base contract. This is going to be some settings. Now we're going to talk about this in a minute, but let's go over what are the functions here. So we have voting delay. This is exactly the voting delay, which we're going to do super.voting delay. We're going to get from this governor settings contract that we're going to set in a minute. We have voting period that we're going to set in our governor settings, which is this one right here. And again, if you want to like look at all these contracts, you absolutely can, right? If we go to contracts, governance, extensions, we have all these in here, right? So if we look at governor settings, we can see it has voting delay, voting period, proposal threshold, and those are right in its constructor. And that's exactly what we're setting. Right, we're setting voting delay, voting period, and then the proposal threshold. And then we're also going to make this customizable as well. And the rest of these, that's exactly what they're doing. Calling the quorum from the super, get votes. And then again, the super is those inherited contracts, get the state. And then we have some interesting functions. We have propose. This is what we're actually going to do to propose new governance. We have proposal threshold. And then we have execute, which executes a queued proposal. Cancel. We have executor, which is going to be who can actually execute stuff. We're actually going to make it anybody. And then supports interface, you can basically ignore. But let's make this a little bit more customizable. So we have iVotes token. This is going to be our governance token. We have the Timelock controller, Timelock. This is going to be the Timelock controller that we make in a minute. And again, we need this because we don't want to let any proposal just go through once it passes. We want to give people time to get out. But let's add a UN256 voting delay as a parameter here. And for voting delay, we're going to do this. We're going to set it as our governor settings. We're going to do a uint256 voting period. And we're going to add that right here. And this means 45,000 blocks is approximately 1 week. And that's what that means. We're going to leave proposal threshold as 0 because we don't really want to change that. We want to let anyone make a proposal. And then we're just going to add uint256 underscore quorum percentage to this. So governor votes, quorum percentage, quorum percentage. So now this is completely customizable for voting delay, voting period, quorum percentage for whatever you want it to be. And believe it or not, that's it. Now you have a simple governance contract. Thank you, Openzeppelin, for doing 99% of the work for us. So that's it. So this contract, it's going to have all these functions that we're going to go over for proposing, for executing, and for queuing different proposals. Great. Now we got to make a time lock contract here. And this contract is actually going to be a lot easier. So we're just going to do it from scratch. So we're going to do SPDX, license identifier, MIT, do pragma, solidity. No, let's just do this 0.8.0. And then we're going to import from Openzeppelin a contract called the Timelock controller. So if we look at their governance here, they have this Timelock controller.sol contract. And this has all this functionality in here for creating roles, who can actually propose, who can execute, who's a Timelock admin. But it also has these execute stuff in here as well. It's going to work in tandem with our governance contract, right? This is the contract that says that makes sure our governance contract doesn't just push stuff through willy-nilly. So we're going to say, we're going to first import that, import at openzeppelin /contracts /governance /timelock controller. That's all. And then we're going to say contract timelock is timelock controller, like that. And we'll create our little constructor here, constructor. And this takes a couple different parameters. We're going to take a uint256 min delay, which our min delay is going to be how long you have to wait before executing. So this is, hey, once a proposal passes, great, we got to wait this minimum delay. Then we're going to do a list of proposers, an address array, memory of proposers. And then the proposers is the list of addresses that can propose. For us, we're just going to say everyone's going to be able to propose. And then last, an address array, memory of executors who can execute everything. And we're just going to say executors who can execute when a proposal passes. And again, we're just going to say everybody. And the reason we need these is because we need to pass these to our timelock controller. This constructor is expecting three parameters. So we'll just do timelock controller, min delay, proposers, executors. And that's it. So this is going to be what owns everything. It's the time lock that's going to be owning our box. It's not the governor contract. The governor contract is where we're going to send our votes and stuff, but it's the time lock that actually everything needs to flow through in order for governance to actually happen, because we want to make sure we have this min delay, we go through the right process and everything. And believe it or not, that's everything. That is all the code you're going to need as far as the Solidity goes to create a governance, to create a DAO. So we even do here on hard hat compile. Make sure everything's compiled, and ta-da. We've done it. We've done most of the hard work. Now, we're going to flip over to actually writing the scripts to deploy and to interact with everything using TypeScript here. At this point, if you're like, oh, I already learned everything that I wanted, I don't use hard hat, I use some other tool. This is where I challenge you to go out and I challenge you to try something else. Now, if you've reached this point, I just want to give you a huge congrats because you have taken the steps to build your own DAO, build your own governance model. That's all the Solidity that you really need. You can take that, deploy that, and you're good to go. But of course, we know that there's more to being a smart contract developer than just the Solidity. You got to do the tooling right too. So let's go ahead and we'll jump into writing those TypeScript scripts to actually do this. And again, if you want to see a Python version of this, go check out a link in the description to see the Pythonic version of this. And of course, don't forget to smash that like button, subscribe, leave a comment on how you're doing so far. And of course, give yourself a pat on the back. Great job. You're doing amazing getting this far. Congrats. Let's jump in. All right, so we're back here. We've written our smart contracts already. Check. Wasn't that easy? Right? This was way easier than you thought it would be. Now we're just going to write our deployment scripts, and then we're going to write our scripts to interact with them. Again, my full repo also has tests, but we're just going to write some scripts, and then feel free to check out the tests yourself. So let's write those deployment scripts. So we're actually going to be using a package for our deployment called Hardhat Deploy. It is absolutely phenomenal for Hardhat for making your deployments much, much easier. We're going to scroll down to installation, and we're actually going to go ahead and install this. So typically you could install it like this. Well, we're going to use Yarn, but we're going to do kind of the more safe way, which looks a little wonky, but I'm going to explain it, right? So instead of npm install, we're going to do yarn add -- dev, and then this whole thing right here. So we're going to do yarn add -- dev, and then just paste that in here. So this is going to be at Nomic Labs /hardhat -ethers at npm : hardhat deploy ethers. And what this is doing is we're basically saying hardhat deploy ethers is going to be overriding this hardhat ethers thing. And we're also going to add ethers as well. And then once we add this, we can check our package.json, and we can see we have hardhat. We have hardhat ethers, which is being overridden by this hardhat deploy ethers. And then additionally, we're going to want to add hardhat deploy. So we'll do yarn add -- dev, hardhat -deploy. And what this is going to allow us to do is instead of having to write scripts and do all this stuff that kind of makes it hard to save your deployments and everything, we're going to just create a deploy folder where we're going to add all of our deploy scripts in here. So I absolutely love this package. It makes deployment really, really easy. So in here, we're going to create a new file. It's going to do 01. We're going to go step-by-step deploying everything. We're going to call this deploy governor token .typescript. That's going to be the first thing that we're going to do. Also, we're going to change this to TypeScript. Ta-da, we now have TypeScript, yay. Now, the one thing that is kind of nice about doing kind of that advanced TypeScript thing that the hard hat kind of gives at the beginning is you don't have to install all the TypeScript stuff yourself, but we do. So we're going to do yarn add TypeScript, type chain, TS node at type chain / ethers v5. Now, this is a lot of stuff. Don't worry. Type chain / hard hat at type / chai at type / node. And then we'll make sure this is all dev --dev. I know this is a lot of stuff, but this is all the stuff to make it TypeScripty. You can absolutely do this in JavaScript if you want. You just have to do JS files and ignore the typing. So, but feel free to do whatever you want to do here. All right, cool. And we should be okay here. Let's go into our governor token here and we'll create a deploy script. So the hard hat deploy GitHub repo has a little demo boilerplate code for you to actually do your deploy script. So feel free to reference here if you get lost or confused. So what we're going to do is we're going to import the hard hat runtime environment from hard hat / types. And you'll see why we need this in just a second. And then we're also going to import deploy function from hard hat deploy / types. And these are the two main things you need to create a deploy function with hard hat deploy. So we're going to create our function. We're going to call it const deploy governance token. It's going to be of type deploy function. So in order for these to actually work, we just create a whole bunch of deploy functions that we run with hard hat. And this is going to be an async function. It's going to take the hard hat runtime environment as an input parameter that we're going to call HRE. Okay. So when we run hard hat deploy, which you'll see in a second, we're actually passing our fake hard hat chain that gets spun up in the background for us, right? And we can even do like console.log, hello. And if we do yarn hard hat deploy, actually, before we even do that, if we do yarn hard hat -- help, you'll see since we imported hard hat deploy, oh, excuse me, we need to add this to our config first. In our config, we're going to need to do top import hard hat deploy top. We're also going to need to import at nomic labs / hard hat ethers. We're also going to need to import at type chain / hard hat, and then we'll leave it there for now. We'll have to import more stuff in a second, but we'll just leave it like that. Now, if we do yarn hard hat -- help, we should see a new task in here. And we do, we actually see a ton of new tasks, right? Available tasks, check, clean, compile, console, deploy. And this is the new task that we have that actually deploys all of our contract. Anything that's in this deploy folder, hard hat will go ahead and run. So right now in our deploy folder, all we have is this console.log hello. So if we run yarn hard hat deploy, we should see it just print out hello. It'll spin up a new blockchain in the background, file all of our projects and everything, do some type chain stuff. And it says, you'll see this a lot, deploy script.func is not a function. That's because we actually need to export this now. So we'll do export default deploy governance token. That's why it's getting mad at us. Now we'll run yarn hard hat deploy and boom, we see hello. So this is how we can actually deploy all of our scripts and we can run everything that's in this deploy folder in one go, which is really helpful. So let's go ahead and deploy our governance token first, right? And this will get a lot faster as we go along, don't worry. So delete this. And first we're going to say const, we need an account to deploy this first. So we'll say const get named accounts, deployments, and network equals HRE. And this is going to be a little bit more advanced. This is hard stuff. This is the slick stuff we're doing here. We're getting these from our hard hat runtime environment, which is being updated from hard hat deploy. So get named accounts is a way for us to actually import accounts from our hard hat config right into our deploy script. So we're going to go to our hard hat config and we're going to create a new config that's a little bit nicer than this. So first we need to import the hard hat config type. Since we're using TypeScript, so we're going to import hard hat user config from hard hat /config. And we're going to create a config. So I'm just going to comment this out for now. We're going to say const config. It's going to be of type hard hat user config equals, and this is where we can add a whole bunch of stuff. So let's say our default network is going to be hard hat, which is kind of our local fake blockchain. And then we're going to say solidity is 0.8.8. And then we're going to do this thing called named accounts, which is what we came here in the first place for. So this is just a list of accounts that we can use. So for accounts, we'll say deployer. This will be the name of our account that does all the deploying. And we'll just say default is going to be 0. So whenever we run on any chain, our 0th account is going to be named deployer. What other thing that we need to do is we need to add our networks here. And there's actually two networks that we're going to have. We're going to have hard hat with a chain ID of 313337. And we're also going to have localhost of chain ID 31337. Now, these look like they're pretty much the same, and I understand that, but they're not, and you'll understand why in a second. But we need them for now just to tell hard hat, hey, here are the development fake blockchains that we're working with. Okay, so this is kind of our basic setup here. Okay, I know that was kind of a lot, but now that we have get named accounts, we have network, right? Because anytime you deploy something, it's going to be on a network. And when we deploy something, if you run yarn hard hat node, what hard hat is going to do is going to spin up a fake blockchain in the background. Oh, it's going to get mad at me for a second. Oh, I forgot to add export default config, right? We need to export the config to tell hard hat that we're using this version of Solidity. Now, if we run a hard hat node, you'll see why we added these two networks up here, hard hat and localhost. We actually get spun up our own fake blockchain. We get accounts, we get private keys, we get everything, right? This is a hard hat node running in this terminal, right? When you run hard hat node, oddly enough, it's actually the localhost network. It's not the hard hat network. When you're using hard hat deploy, it's going to be the localhost network. Or excuse me, when you use hard hat node, it's actually going to be the localhost network, not the hard hat network. The hard hat network is what it uses when it runs tests. Localhost is when you run this hard hat node and have this kind of fake blockchain running in your terminal. So that's what the localhost is. Cool. We'll control C, we'll kill that. But all right, great. So now the stuff is actually working. So get named account, deployments is going to be a whole bunch of stuff from deployments. You'll see in a second. And network is the network that we're on. Okay, great. So now we're going to grab const deploy log equals deployments. So this deployments object comes with this deploy function and this log function. This log function is kind of nice for doing logging. And then we're going to grab const deployer equals await get named accounts. So we're grabbing from our config this deployer account, right? And it's always going to be the 0th index. So it's defaulted to the 0th index for whatever account that we work with. Great. So we now have an account to deploy stuff from. We have a deploy function. We have all this stuff. We're looking pretty good. Cool. So sometimes I'll do like a log deploying governance token, and we'll say const governance token equals await deploy, and then the name of the contract, which is governance token, comma. And these are all the parameters that we're going to pass to it. So we're going to say from deployer, doesn't take any arguments. So args is just going to be blank. We're going to do log to be true. So we'll get some logs printed out for us. And then I have this wait confirmations attribute set in my GitHub repo. For now, we're going to ignore this. But if you follow along with my repo and you want to auto verify stuff, this is something that you're going to want to use. So you need to wait some amount of blocks for this contract to be deployed before you can actually go ahead and verify it, right? Because if you're using Etherscan or something, you're going to need to wait you're going to need to wait a few minutes. So check out my GitHub repo for this wait confirmation stuff. I'm just going to ignore it for now. Additionally, in my GitHub repo, I have this verify function where we check to see if it's on a development chain. And if it is, we don't verify it. But if it's on like Etherscan or something, we go ahead and verify it. So be sure to check the GitHub repo to learn how to just auto verify without having to do anything. Now, if we just do this part, and we can even do deployed governance token to address governance token dot address, and we'll do yarn hard hat deploy. Boom. So we spin up on a fake hard hat network. We do deployed governance token to address. Boom. And this is how we deploy a fake test deploying this to our own little network here. Great. So this token's been deployed. We have our deploy script. Yay. Should I zoom out a little bit? Let's zoom out just a little bit. Great, that's the whole thing. Now we're gonna add one more thing here. We're gonna add something called a delegate function. Now, when you actually deploy this contract, nobody has voting power yet. The reason is because nobody has the token delegated to them. So we wanna delegate this token to our deployer, right? So we're gonna call this delegate function. So we're gonna create a new function called const delegate, and it's gonna be an async function. It's gonna take a governance token address as a string. It's going to take a delegated account also as a string. So we're basically going to say, who do we want, delegate, who do we want to be able to vote with our token? Okay. So we're creating this async function called delegate. And how do we do this? Well, we say const governance token equals await ethers dot get contract at, and it probably ported ethers for us. From hard hat, it auto did that, which is great. That's what we want. Once it saw ethers, thank you, VS Code. Await ethers.get contract at, and we're going to say we want our governance token, which is at contract governance token address. And I have auto format on saves, which is why it keeps formatting like that. This should be delegated account. Okay, cool. So we have our governance token contract. Now we can do const tx or transaction equals await governance token dot delegate this delegated account here. And then we can do await. We'll wait for this transaction to be confirmed by one block. And then we'll just do console.log checkpoints, await governance token dot num checkpoints delegated account. So what is this doing? So we have this num checkpoints function, which we can go check to see on that ERC20 token what this is actually doing. But basically what this whole thing is doing, we have this delegate function that we haven't used it, but when somebody calls us, we're saying, hey, you can use my vote. Take my votes and vote however you want. And that's what this delegate does. Now, if we look at this token, ERC20 extensions, ERC20 votes, we look at num checkpoints, we can see how many checkpoints that account actually has. The reason this is so important is because when, again, like I was saying, when people do a vote, they do it based off some checkpoints. And anytime you transfer a token or delegate a token, you basically call this function move voting power, which happens at the back end, which writes the checkpoint and says, hey, at checkpoint X, here's what everybody has for voting powers. And that's why these are so important. And I know I said before, it's every block, but it's actually just every checkpoint. Whenever these checkpoints are updated, that's going to be a lot cheaper on gas than if we just did every single block, right? That'd be kind of insane. So the checkpoint for this governance checkpoint, and we'll see what it actually is in just a second. So we'll even do await delegate governance token dot address and deployer. And we'll say log delegated. Now when we run this function, yarn hard hat deploy, we have one checkpoint, which makes sense, right? Because this was just deployed. It was just delegated. This address has one checkpoint. That's it. And the reason I checked for this is because if you see 0 checkpoints here, it means you haven't delegated correctly. So be sure to check for checkpoints. But that's it. We have our deploy governance token contract done. Bravo. Let's move on to the next one. So what do we want to do after we deploy our governance token? Well, let's deploy that Timelock, deploy timelock.ts. And we're going to copy a lot of the stuff over from here. So I'm actually going to, oh, and then sometimes you'll get some weird linting errors here. I just do that ts ignore there, and sometimes you'll get it here too. Oh, actually, we don't even need network. Okay, cool. Yeah, you don't even need network. Whoops. But sometimes you get some weird linting errors. Sometimes VS Code has a hard time understanding like this overwrite thing that we did. So just run that ts ignore if it gives you some linting errors. Anyways, yes, we have this O2 deploy Timelock here. We're going to deploy our Timelock contract, and we're going to borrow a lot of the things that we did from here. So I'm just going to come back here. We're actually going to copy paste these 2 top bits. Again, we're going to do const deploy Timelock is going to be a deploy function. It's going to be an async function that takes the hard hat runtime environment as a parameter, and cool, nearly exactly the same start. And then we're going to grab these first 3 lines, or first 4 lines, I guess. Paste those in. We're going to be getting those exact same things here. And we're going to be doing nearly the exact same thing. So we'll do log, deploying, Timelock, deploying Timelock. And we'll do const Timelock equals await, deploy Timelock. And we'll add some parameters in here. We'll say from deployer. Now, does this take some arguments? It absolutely does, right? We can take a look at the Timelock. Min delay, proposers, and executors. So what do we want our min delay to be? Well, this is a value that we're actually going to use a lot. So what I usually like to do is I create a new file called helper hardhat config.ts. And right at the top, I'll say export const min delay, and I'll have this delay be whatever I want it to be. So let's just go ahead and do 3600, which is going to be approximately an hour, right? You got to wait this many seconds. I think that's an hour. I'll whip out the old calculator. There's 60 seconds and 60 minutes. Great. That's going to be 1 hour. So wait 30 minutes, and we're going to go ahead and import that here. We'll say import min delay. Oh wow, it auto-completed for me. Great. From helper, it's down directory, helper hardhat config. And that's going to be our first argument here. Our second argument is going to be a list of proposers. Now we're going to leave it blank for now. And also the list of executors, we're also going to leave it blank for now. We're going to update this in a minute, and you'll see why once we get there. We'll do log true. This also has a wait confirmations thing in my GitHub, but we're going to skip that for now. It also has an auto verify. We're also going to skip that for now. Then we just need to export default, deploy Timelock, and boom, we should be good. So let's try to run this. Yarn hard hat deploy. So now this should run both of these. Great. Deployed governance token, deployed Timelock. Perfect. We are cruising. Now what? We want to deploy that governance contract now. So let's go ahead and do that. So we're going to do O3, deploy governor contract.ts. And you guessed it, this is going to look pretty similar to what we just did, right? So in our deploy Timelock, let's go ahead and just grab those top two things. We'll paste it in here. We'll do const deploy governor contract, which is going to be the deploy function. It's going to be an async function, taking a hard hat runtime environment. Let's see if I can close this for now. And we can even go back and grab these 3 lines from our O2 deploy Timelock, paste that right in here because we're going to need to get the exact same things. And additionally for this, we're going to need to get the governance token and the Timelock contract. So we'll do const governance token equals await get, which actually we have this get function that comes from these deployments, which literally just goes out and gets these deployments. So we'll say get governance token. And then we also need to get the Timelock. So await get Timelock. And we need these to pass as parameters for our governor contract, right? Because if we open up the governor contract.sol, we look at the constructor, it takes the token, the Timelock, voting delay, voting period, and quorum percentage as input parameters. So we'll do a quick log, deploying governor, hello. And then we'll do const governor contract equals await, deploy, and we'll deploy the governor contract. I'm not sure if I'm spelling this right always, but that's fine. And we'll do the parameters once again. So it's going to be from deployer. Args are going to be this list of args. What's the first thing that it needs? It needs the token first and then the Timelock. So we'll do governance token.address. Then it's going to need the Timelock.address. And it's going to need a voting delay, voting period, and quorum percentage. So these are also values that we're going to make a lot. So let's open back up that helper hard hat config and let's create those as well. So we'll say export const voting period. And we'll say this is going to be 5 blocks. We'll do export const voting delay. This is going to be just 1 block, which I know is really quick. And then we're going to need export const quorum percentage, which we're going to say is 4. 4% of voters always need to be voting. Excuse me, 4% of voters need to have voted for a vote to pass. Great. So we're going to do voting delay, voting percentage, quorum percentage. So we'll import those. So we'll do import, voting delay, voting period, quorum percentage from helper hard hat config. And then we have those. Delay period percentage. We can just do comma voting delay, voting period, quorum percentage. And then we'll say log is true. And again, this one as well has a wait confirmations and an auto verification that we're going to totally ignore. And then we'll export default, deploy governor contract. Okay, we're getting spicy here. Let's just make sure this works. Yarn hard hat deploy. We should see 3 contracts deployed here. Nothing to compile. Governance token deployed, Timelock deployed, governor contract deployed. Let's go. All right, now we're not done yet. We have 2 more deploy scripts to do. The first one, we're going to call setup governance contracts, okay? And this one's really important. But right now, our Timelock contract has no proposers and no executors, right? So we want to change that. We want to only allow for the proposer to be the governor. The governor contract should be the only one that proposes things to the Timelock, and then anybody should be able to execute. The way that this works is we say, hey, the governance contract proposes something to the Timelock. Once it's in the Timelock and it waits that period, anybody can go ahead and execute it. So governor contract, everybody votes and everything. Once a vote passes, governor says, hey, Timelock, can you please propose this? Timelock goes, yeah, sure, but we got to wait this minimum delay. Once this minimum delay happens, anybody can execute it. Now, this would be really cool to do an integration with chain link keepers, by the way, for the chain link keepers to automatically execute. Oh man, I should build that next. Anyways, so we have to set this up so that these work as such. So we're going to create a new deploy thing called 04 setup governance contracts.typescript. And this is going to be the code that does all this setting up. And this is going to look really similar once again to all of our other deploy functions. So we'll go ahead back from 03. We'll paste these two top ones in here. Of course, we're going to do const setup contracts. This is going to be a deploy function. It's going to be an async function. It's going to take HRE, hard hat runtime environment as parameters. And then that's the winner right there. Cool. And we're going to be grabbing those same three from the top. As you can see, this gets a little bit easier because it's kind of repetitive, right? We're going to grab that bit right here. And now we're going to get those contracts so that we can interact with them. And this is another reason why hard hat deploy is so nice, because we can just do const timelock equals await ethers.get. And then actually, let's go ahead and import ethers from hard hat, import ethers from hard hat. And we'll even drop a little TS ignore here. Ethers.get contract. We want that timelock contract, and we say we want to attach it to the deployer. So whenever we call a function on it, it's going to be the deployer calling that function. Then we want to do const governor equals await ethers.get contract, governor contract. And this is also going to be attached to the deployer. Great. Now we're going to do log setting up roles. And we're going to set up the roles, right? Again, we're setting it up so that only the governor can send things to this time lock, because the time lock is going to be, you can almost think of the time lock as like the president, right? So everything goes to the Senate, the House of Representatives, which is the governor, and then the president just says, yeah, sure, we just got to wait this minimum delay. But the president will be the one to actually execute everything, which I'm not actually sure that's how it really works in politics. But for now, that's what we'll pretend. The president or the time lock is the only one that can actually do anything here. So the way that this works is we're actually going to get the bytes codes of different roles, right? So if you look at these time locks here, so we'll do Openzeppelin contracts, and we go to the governance here. We go to timelock controller. It has these things called proposal role, executor role, timelock admin, etc. And these are just hashes of these strings here. But these are bytes 32 saying, hey, anybody who has this byte 32 is a proposer. Anybody who has this byte 32 is an executor. Anybody who has this byte 32 is a timelock admin, etc. Right now, our deployer account is the timelock admin. And that's bad. We don't want that. We don't want anyone to be a timelock admin, right? We don't want anyone to have power over this timelock. We don't want any centralized force here. So what we're going to do is we're going to do const. We're going to get those roles, proposer role. It's going to be await timelock.proposer role. And if you're familiar with multi-call, this would be a great time to do multi-call. I'm going to copy paste that whole line, executor role, executor role. We're going to copy this whole line, admin role, and this is going to be timelock admin role. So these are these three roles that we need to fix, right? And let's go ahead and fix them. So the first thing we're going to need to do is we're going to need to do const proposer tx equals await timelock.grant role, proposer role, to our governor.address. So saying, okay, governor, you're the only one who can actually do anything. Once you tell the timelock to do something, we'll wait for the timelock period to be over, and then we'll be done. And then we'll just do an await proposer tx.wait one block just to make sure. Now we're going to do the const executor tx equals await timelock.grant role, executor role to nobody. We're going to execute this. We're going to give this to nobody. We're going to say address 0, which is going to be something that we're going to want to add. If we go to our helper hardhat config, we'll say export const address 0 equals 0 by, you can just copy paste this if you want. There's a couple other ways you can do this with ethers as well, but we're just going to do it like this. I like having my const like this, and then we can just import it. Say import address 0 from / helper hardhat config. So we're giving the executor role to nobody, which means everybody. So once a proposer's thing has gone through, anybody can execute it. So we'll say executor tx.wait one, we'll wait a block, and then we got one more to do here. We need to revoke role. Right now, our deployer count owns that Timelock controller, right? And that's how we can actually do these transactions. We can actually grant role because our deployer account owns it. But now that we've given everybody access and given all the decentralized access we need, we want to revoke that role. So const revoke tx equals await timelock.revoke role, admin role from deployer. And then we'll do tx.wait. Now guess what? Anything that Timelock wants to do has to go through governance. And nobody owns the Timelock controller. It's currently, after this runs, it's impossible anyone to do anything with the Timelock without governance happening. And then of course we're going to export default setup contracts. Great. And then the last step that we need to do here is we need to deploy the contract that we actually want to govern over, right? That box contract, that real basic contract. So we're going to create a new one, O5 deploy box.ts. And we're going to do some of the same exact stuff we've done, right? So we're going to grab these two here, paste it in. Const deploy box is going to be a deploy function equals async function, HRE, hardhead runtime environment. We're going to grab those first 3 lines with the TS ignore, just like that. And now we're going to deploy this box. So log deploying box. And we're going to do const box equals await deploy box. Give us some values from our deployer. Args. Does this have any args? Let's open up box.sol. I don't see a constructor. Wow, this is the easiest contract out of all of these though. No constructor. And then we'll just say log. It's going to be true. And again, if you want to check out my GitHub repo for that confirmations bit, feel free to do so. Needs to be a comma here. And right now, our deployer has actually deployed this, right? Not our Timelock. So we want to give the box's ownership over to our governance process. So now we're going to do, we say const Timelock is going to be await ethers.getContract. The same thing as before, Timelock. We're going to grab ethers from hardhat, import ethers from hardhat. Then we're going to do a little ts ignore. It's being finicky. And then we're going to transfer the ownership of our box to this Timelock, okay? And now, so this is actually what's known as a box deployment. So before we do that, we have to get the box contract. So this is a box deployment object, which doesn't have contract functions. We want to get the box contract object. So we do box or const box contract equals await ethers dot get contract at box. And then we'll just do, box.address. You could also do get contract. Actually, both of these pretty much, if you have the address, you can just do box.address. But you could also do get contract here. Either one works. Now that we have the box contract, we do const transfer owner tx equals await box contract dot transfer tx, or excuse me, dot transfer ownership to our Timelock dot address, Timelock dot address. And then we just do await transfer ownership tx dot wait 1. Do a log. You done it. And then we'll do export default deploy box. Ooh, let's see if this works. So we just did everything. We're deploying the governor token, deploying the Timelock, which owns the governance process. We're deployed the governance process. We're setting up the governance process so that it's totally decentralized. And then we deployed and set up our box so that it only can be updated through a governance process. Let's see if it works. Yarn, hard hat, deploy. Let's see if it works. Bada boom, you done it. So you've just set up a script to set this entire governance process up so you can build your own DAO. Oh, you still here? Well, hell yeah, you are. Congratulations on getting this far. We have one more piece to go. We just got to write those scripts so we can actually interact with this. We can actually do a governance. We can actually see exactly what the governance process looks like. Now, again, if you didn't watch my last video on DAOs, be sure to watch that because that's going to give you all the context for this part here. And if you're still watching, 100%, smash the like button, hit the subscribe, leave a comment in the comment section below. It really helps the channel out. So proud of you for getting this far. We're almost there. You're getting there. One more to go, and then you're home free on building your DAO. Let's get back into it. All right, so now we're gonna make some scripts to actually interact with, propose, queue, and vote on anything that happens in our DAO. And these are the scripts. These are kind of the things that you would do on your front end when you build this, when you build your DAO on the front end. Or you could do an integration with Snapshot or Tally or something like that. And again, if you want to see kind of the full functionality, on the GitHub, I have this testflow.ts. It's not the greatest test here, but you can also check this out because it also does a soup to nuts demonstration of going through this exact process. So let's go ahead and start making some scripts. So we're going to create a new folder called scripts, and this is where we're going to put all of our scripts. Now, the process for this is going to be, we're first going to propose something, right? Maybe we're going to propose that our box contract stores the value 77. Right? Because when it first gets initialized, it's going to start with 0. So maybe we'll propose it could start at 77. Once proposing is done, we start voting on it, right? Once a proposal is in, we're going to vote on whether or not we want the proposal to go through, right? Yes or no. And then if it passes, we go to queue and execute. We queue first, and then we execute. I'm just putting them both in the same script to make it easier. So let's start with propose here, because this is going to be the first thing that we're going to do. So let's create a new function. We'll call it async function, and then we'll actually export it too. Export async function propose. And we're going to be in here for a little bit. So let's clear everything out. And okay, cool. So this is where we're actually going to propose on our governor contract, right? So we're going to propose on our governor contract. So the first thing we're going to need, of course, is going to be the governor. So do const governor equals await ethers.get contract governor contract, right? Since we're doing ethers, we're gonna have to do import ethers from hardhat. And then we're still getting that fun little thing. We'll do a little @tsignore here. Cool, so we have the governor contract here. We're gonna need the box contract because we're gonna say, hey, we want to propose the box contract changes the store value. So we'll do const box equals await ethers.get. And this is geth contract. We want get contract, say box. And those are the two main ones that we're going to need just to start. Now, if we look at the propose function, right? If we go to governance, we go to governor, and we look at that propose function. This is what it looks like. Now, I explained this propose function in my last video. So if you haven't seen it, be sure to go back and watch it, right? Because it'll give you everything that you need to know here. But basically, we pick a list of targets, which our list is just going to be just our box contract. These are the targets that we want to call functions on. We do values like how much native ETH we want to send, which we're not going to send anything. We have bytes array call data. So this is going to be our encoded parameters for the function that we want to call, and then a description. So that's exactly what we're going to do here. So first we need to figure out what we're going to do. So we look at box, we're going to call this store function with this new value here. So we need to encode this box here. And we also need to encode what we want to upgrade it to, right? So we have to code all the function parameters. So we'll do const encoded function call equals box. And the way we can get this, box.interface.encode function data. And this is what actually turns it to being this bytes call data, right? So we're encoding everything, and this encoded function, you can find this in the ethers documentation. We have to pass it the function to call, and then the arguments we want to pass, right? And this is how we actually get that. So let's get these arguments here. So we're going to say args. We're going to make our proposed function a little bit modular. So we're going to say args is going to be an array of anything, and then we're going to say function to call is just going to be a string, right? And then right at the bottom, we're actually going to call this proposed function. So we're going to say propose, and let's say we want to give it 77. The function is going to be what? It's going to be store, and that's a string. And this needs to be a list. So we're going to do it like this. Now we're actually going to use this all over the place. So since we're going to be using this all over the place, we want to stick them in this hardhat helper config. So what we're going to do is we're going to say export const new store value equals 77. And we're going to do export const func equals store. And our propose, we're just going to import those. So we'll do import new store value, and then also func from helper hardhat.config, and it added it in for us, which is great. So we'll just put new store value in here, and then we'll put func in here. And I know this might look a little confusing, but basically the first thing we're gonna do is we're gonna call this proposed function, which calls, proposed function up here. Now we're gonna do some fun little then process.exit 0, and then we're gonna do .catch error, which if there's an error, basically we'll just do console.log error, and then process.exit 1. And this is pretty typical setup for really any script you work with in hardhat. So Great. So we have constant coded function call, which has this function to call an arg. So we're basically combining these into this bytes thing. And we can even print this out. You can see what this looks like. So we can do console.log. You see that this is like this crazy bytes thing here. And the way we can kind of test this, we'll do yarn hardhat node, which will spin up, again, our fake blockchain. But additionally with hardhat deploy, it'll deploy all of our contracts here, right? We can see time lock, governance, everything that we need for testing locally has already been done. So once we have that up, we can then do yarn hardhat run scripts propose.ts -- network localhost. This is important to do, again, because when you're working with a node that's running locally, you're going to be working with localhost. We'll see what it prints out here. No contract name governor contracts. Governor contract. Let's try that again. And cool, you can see this is what that encoded function call and arguments looks like. It's this really long byte string. But if you were to decode this using the box interface, you would get the function call and the arguments, which is really exciting. So cool, we've encoded it to bytes. And now what do we want to do? We encoded it to bytes, and now we're going to create that proposal transaction. So we'll do console.log. We'll say proposing. We'll say function to call on box.address with args. And then we also need to pass a proposal description. So we're going to say proposal description. We'll even do it on new line. Why not? Proposal description, which we don't have yet. Don't worry, we're going to get it. So we also need to pass a proposal description, right? Because we have down here description. So let's add another parameter to our propose here. So we'll say proposal description, and this will be also a string. Down at the bottom, we're going to need a proposal description as well. So we'll create a proposal or export const proposal description. It's just going to be some string. So we'll say proposal number 1, store 77 in the box. So that's the description here, comma proposal description. And then we need to import this for our helper config. Okay, perfect. So now we have the new store value, the function, the proposal description, and we can now call that propose bit that we were just looking at. So here's what we're going to do. Const propose tx equals await governor.propose, and we need to pass those lists. So first is going to be a list of targets, which for us is just the box.address, right? Only one target. And again, these little brackets make it a list of values, which is just going to be 0, a list of encoded function calls or our bytes data basically, and then the proposal description. And then we're going to do propose tx.wait1. Now, if you remember from Compound, this is going to be the exact same. If we go back to Compound, back to governance, this transaction is literally going to be the same as this created thing here, right? And if we scroll down, click more, we can see decode input data, that those exact same things on a Compound proposal, right? We have targets, values, signatures. Well, okay, this is a little bit more, advanced here. It's using signatures, but it's got the same thing, call data, and then a description here, okay? Now, since we have a voting delay, people actually can't vote until the voting delay passes. Now, with a local blockchain, nobody's actually processing blocks and time doesn't really pass as quick as we want. And so we're just gonna speed things up for our own testing purposes. So the way I normally do this is I create this variable called development export const development chains, and I'll add hardhat and localhost. Because we can actually do things with our own local blockchain. We can actually speed up time, we can speed up blocks, we can do all this crazy stuff. So usually I'll actually import this in here, and then I'll do a quick if. And I'll say, if we're on a development chain, let's just go ahead and speed things up for us, right? So I'll say if development chains dot includes network.name, and then we can import network from ethers as well. And this is what I was talking about, those super sick skills that you're gonna learn. If it includes network.name, then we're going to go ahead and move the blocks forward, right? Because if we're not on a development chain, we can't actually move blocks. So what I'll do here is actually I'll create a new folder called utilities, new folder, or utils. And in here, I'll create a script called move blocks.ts. And we're just going to create this little function called move blocks, which moves blocks for us. And you'll see how we do this. So we're going to import network from hardhat because we want to speed up that voting delay. We'll do export async function. We'll call it move blocks. And it'll take an amount, which will be a number. So how many blocks that we actually want to move. And then we'll just do console.log, moving blocks. And we'll say for let index equals 0, index is less than amount, index plus plus. What we're going to do is we're going to do await network.provider.request, and we're going to request method EVM mine. So basically we're mining for our local blockchain, right? So you can find these docs in the Hardhat docs, in the Ethers docs. There's a couple different places you can find these, but this is kind of this really cool hack that we can use to actually move blocks forward on our local chain. Now, obviously this won't work on an actual chain because you'd actually have to do the mining, but on our local chains, we can absolutely do this. So we've exported this move blocks function, and we're actually going to grab that from our propose. So we're going to do import move blocks from utils blocks. And we're going to say down here, if we're on this development chain, we're going to do await move blocks, and then we'll move blocks by that voting delay that we were talking about, right? Because we need to wait that voting delay in order to move. And it looks like it auto imported for us from our helper hardhat config. I told you we were going to use that a couple times, but we're going to move blocks by that voting delay. Now this proposed transaction does some stuff that we actually want, right? So one of the big things that it wants is it has this proposal ID. And if we scroll down to the event that it emits, it ends up emitting this proposal ID. We actually need the proposal ID for later on when we actually go to vote. So what we're going to do is we're actually going to do const propose receipt equals propose tx.wait, and we're going to get those events from this proposed receipt. So we're going to say const proposal ID equals propose receipt dot events, the 0th event, because that first event is the only one we care about, dot args dot proposal ID. This is how we get this proposal ID from this emit proposal created event. A couple other ways to get proposals, to get events in Hardhat, and I got a video on it on my YouTube if you want to go check that out. Something else that we want to do is maybe we want to see what the deadline is or the snapshot. You can go ahead and check my GitHub to kind of see what the snapshot looks like, or the deadline, basically how long we have to vote, you know, what snapshot you're working with and all these different things. But for now, we're just going to stick with the proposal ID. Be sure to check out the GitHub for more stuff. Now we want to save this proposal ID. We want to save it somewhere so that our other scripts, so that our vote and our queue and execute know what this proposal ID is going to be when we run those. So what we're going to do is we're going to create this file called proposals.json, and it's going to store all of our proposals. So we're going to say proposals.json. It's going to have all of our proposals in here. So what we're going to do, and we're going to add this to our helper hardhat config. We're going to do export const proposals file equals proposals.json. And we're going to import this at the top as well, this proposals file. And then once we get this proposal ID, what we're going to do is we're going to read all the current proposals. So we're going to say let proposals equals json.parse, and we're going to do fs.read file sync from this proposals file, and we're going to pass it to UTF-8. Now this fs we don't have yet, so we're going to need to import fs. So we're going to do yarn add fs like that. If we look in our package.json, oops, I should have saved that as dev, but I didn't. Oh well. Doesn't really matter. Now that we have that, we can actually import this into our TypeScript. So we're just going to say import star as fs from fs. And now we can actually use fs. F is a way to kind of read from files. Now we can get this list of proposals. So if we go to proposals.json right now, we'll just make it a blank JSON. So the first time we run it, it'll just be blank, but later on it'll have stuff in it. And the way that we're going to save these proposals is we're going to say proposals of network.config.chain ID, and this little bang to say, yes, there will be a chain ID, .toString. We're going to store them by their chain IDs, right? So for each network that we have a proposal to, we'll store it like that. And then we'll do .push proposal ID.toString. And then we'll write it back. So we'll do fs.write file sync proposals file, json.stringify proposals. And awesome. And that's all we need to do. So let's go ahead and actually run this. And then I have some console.logs in here saying, hey, here's what the proposal state is. Is it open? Is it voting? Is it canceled? You know, etc. What the proposal snapshot is. Again, check my GitHub for that. But what we can do, now this is done, we can do yarn hardhat node. We'll spin up our little node here. And all the contracts are deployed. And then we'll do yarn run scripts propose.ts -- network localhost. Scripts propose.ts is not found. Propose yarn hardhat run scripts propose.ts. Oops. -- network localhost. Let's try this again. Now you found it. Yay. Oh, it ran into an issue. Proposal description, moving blocks. Can I read property 0 of undefined? Let's see where it got mad at me. Proposal sheet dot event. It is events, not event. Let's try this again on the localhost. Here we go, running. Ran into another issue. Proposal already exists. Okay, so great. So the proposal already exists. Let's go ahead and just like kill the node and restart the node. So you can't have two proposals that are exactly the same, basically, right? So we can't do that. We would need to change the description or something. So we're just going to kill the node and restart. Now we're going to run this proposal again, and then hopefully this one should work this time. Can I need property 0 of undefined? Propose receipt. This needs to be await because it is a promise. Kill this one more time, rerun it. And once all these get deployed, then we're going to go ahead and run this. Now you can see how much quicker this is than if you were to actually send this to a testnet, right? This would have been a lot of waiting, which is no bueno. And we run into one more. Can I read property push of undefined? That makes a lot of sense too, because proposals.json has nothing for chain IDs. So let's do 31337, and we'll put a little list in here. Right now it's an empty list. Now we're going to kill this one more time, kill it. And then once this goes, then we're going to go ahead and do this. Perfect. Now we're going to run this, and now it should save, and everything should be peachy hunky dory. Awesome. Proposal number 1, store in the box. We moved the blocks. And if we look at proposals.json, we now see there's a list of proposals. And this is the proposal ID of that one we just created. Boom. Okay, we made a proposal. Awesome. Nice work. We'll leave that node running. And hopefully we'll just do things right for the voting. So let's create this vote script now. Okay. So now that we proposed, it's time to vote. Let's do a little voting. So this is going to look pretty similar to that script we just created, right? So we're going to do async function. We'll call this main proposal index number. And we're calling this main because we're going to have the vote function be a little bit different. You'll see why. And then at the bottom, of course, we're going to do main index, dot then process dot exit 0 dot catch error, arrow function, console dot error, and then process dot exit 1 main index. We're going to say our index is 0. Constant index is 0. We'll do it like this. Constant index is 0. Proposal index. So we're going to get that 0th index, right? The first index in our proposals.json. So whatever is the first one in this list is what we're going to use, right? And that's what we want. Right now there's only one, so it's easy. So we're going to get that first one in here. So first thing we're going to need to do is we're going to need to grab the list of proposals. So we're going to do const proposals equals json.parse fs.read file sync proposals file utf8. So of course we're going to need to import a bunch of stuff. We're going to import proposals file from /upward hardhead config, and then we're going to do import star as fs from fs. Great, we have fs, we can read stuff, and we can get those proposals. Okay, cool. So we have a list of proposal IDs. Now let's get our proposal ID. We'll do const proposal ID equals proposals of network.config, and then that's not what we want. We want to actually import network. Import network from hardhat network.config.chain ID exclamation mark of proposal index, which for us is going to be 0, right? We're getting that first proposal in the list of proposals. Now we're going to choose how we want to vote. So 0 equals against, 1 equals for, and then 2 is abstain. I don't know why you'd ever abstain. Abstaining costs gas. You could just not vote. But we're going to say const vote way, the way we're going to vote equals 1. And we can also do a reason. So if we go back to our governor, there's a couple different functions we can do to vote. There's cast vote, where we just cast a vote, cast vote with reason, and cast vote with signature, where we actually do a signature here. And I asked this question, hey, what does cast vote by sig do on the Openzeppelin forum? I was like, hey, what is the purpose of this? My hunch was that anyone could then execute this vote on behalf of me if I didn't send the transaction, and that's exactly what it is. This method implements a meta transaction and allows a project to subsidize voting fees. The voters can generate a signature for free, and the project can submit those and pay for the gas. So this is incredibly powerful, and this is the function that allows this cast vote by signature is what allows that snapshot chain link integration that hopefully one of you build. But for us, for this, since we're not implementing these meta transactions, these off-chain stuff, we're just going to do cast vote with reason. Why? Because we want to give it a reason. That's really it. So we're going to say const vote tx response equals await governor dot cast. Oops, excuse me. We need to get the governor contract. So we'll do const governor equals await ethers.getContract, governor contract. And then if we don't have ethers, we should get ethers. Great, let's get ethers. And we'll ignore that. But now we have the contract, so we'll do await governor.cast vote with reason. Spell this right, with reason. And we'll say proposal ID, vote way, and then the reason, which we don't have a reason here. So let's make a reason. Let's say the reason is cost reason equals I like a do da cha cha. If you know that film, you should definitely comment it in the description. So we have a reason. So we're voting for, we're saying, yes, we do indeed want to change the box to 77. And the reason is because I like a do da cha cha. Makes perfect sense if you don't think about it. And then we'll do await, vote.txresponse.wait. So I do some stuff again, checking the state of the proposal where different numbers mean, hey, it's in process, it's voting, etc. We could check on that, but we're going to skip that for now. All we're going to do now that we've voted, we're going to be the only ones to vote. So we're just going to, once again, move the blocks along. Why? Because we want to just get to the end of that voting period. So we're going to do again, if development chains dot includes network.name. Then we're going to do await, move blocks, voting period +1. So we need to import a whole bunch of stuff in here. Proposals file, development. Oh, looks like those got auto imported. We need to import this move blocks. So import move blocks from utils blocks, and then network is in here. And then we need voting period from our helper config, voting period. Okay, cool. And then we'll do console.log voted, ready to go. Now, the reason that I check the proposal state is because there's this state function in the governor contract. So if we look up state, what this does is it tells us what the state of the proposal's in, right? If it's been executed, return that's been executed. If it's been canceled, return it's been canceled. You have the deadline, check to see if it's active, check to see if quorum reached, all this stuff, right? And what you're usually looking for is quorum reached and vote succeeded, right? If both of these happen, then proposal state dot succeeded, right? Otherwise, it's defeated or it's not there yet. I believe this is a 1 and this is a 0. So if you were to call that function and get the state, right now we should get a 0, or excuse me, we should get a 1 for this having passed. If you want to do that as a little extra credit, feel free to do so. So let's see if we did this right. Well, actually, I guess we could have changed this just to vote, but I just wrapped everything up into main. So let's see if this works. Yarn hard hat, run scripts, vote, network, localhost. So we should get a little console.log at the bottom that says voted, ready to go. So now we're voting. We didn't even just go into the hard hat console. We could do yarn, hard hat console, -- network, localhost. And in here, we can actually just check the state right in here. Why not? So we'll copy this line. Const governor equals await ethers.getContract governor contract. Now we can do await governor.state of, if we go to the proposals.json, grab this, paste it in here, and we get a 4. The state of this right now is 4. I forget what 4 means. It's like a proposal state. The proposal state is actually in the iGovernor, so the interface of the governor. We can see 0 is pending, 1 is active, 2 canceled, 3 defeated, and 4 is succeeded. So we are in a succeeded state, which is really good. That's exactly what we want. So let's go ahead and quit now. Oops, excuse me, Control C. Our proposal is now in a succeeded state, and we've actually moved the blocks along the voting period. So voting is now over because we cheated. So now let's go ahead and queue and execute this. Let's do the last bit here. So this is going to look real similar to what we've done already, right? Let's just minimize this. Export async function queue and execute. And then at the bottom, we'll just call queue and execute. And I'm just going to copy paste, but it's that same syntax here. .then, process exit, catch, blah, blah, blah. You get the drill. So in order to queue and execute, we go back to the governor contract, not the iGovernor. Let's go to the governor. First thing we're going to do is call this queue. Now this queue function is actually in the governor timelock, which is in this extensions here. So we can find the governor timelock controller here. And it does exactly the same as propose. We take everything that we did in the proposal and then we just queue it like so. So we pass the exact same values here and that's how we queue it. So what we're going to do is we're going to need to first get those exact same values, which I told you we're going to use a few times. So we're going to import func new store value proposal description helper hard hat config. Right now that we have all that stuff, we'll say const args equals that new store value. We'll do const box equals await ethers.getContract. Let's get that box contract again. We're going to have to import ethers from our hat. And this is going to be from, we're going to do at ts ignore. Then we're going to once again encode this function call to const encoded function call equals box.interface.encode function data. Once again, we're going to do func is the function we want to call, and args. This is looking real similar to our proposed bit that we did. And then we're going to do const description hash equals ethers.utils.getGAC 256 ethers.utils.2utf8 bytes. This will make sense in a second. Proposal description. So with our propose, all we did was pass our proposal description. However, it actually gets hashed on chain, and that's what our queue and execute is going to be looking for. It's going to be looking for the description hash instead of just the pure description, right? And it's going to be a little bit cheaper gas-wise, which is good. So now that we have the description hash, now that we have all the same functions that we did for the propose, it's time to queue them. So we'll do const governor equals await ethers.getContract, governor contract, console.log. We'll say we're queuing, and then we'll do const queue tx equals governor.queue. And we're going to pass the exact same parameters we did with the propose, except for with the hash instead of the actual proposal. So box.address, 0 for ETH. And pass that coded function call, and then the description hash. Great. And then we're going to do, oops, this is going to be await here. And then we're going to do await qtx.wait1. We're going to wait a block there. And great. Then we're all queued up. Now we still have to wait that minimum delay, right? Remember, on our time lock, it's got this min delay thing. It says, hey, once something gets queued up, you can't just execute it right away. You got to give people time to get out. So we're going to speed up time again. So we're going to say if development chains, development chains.includes, and then it looks like it auto imported for me. Development chains, yes, it did. Amazing. That includes network.name. Let's just make sure we import network from hardhat. If it includes network name, then of course we're going to move blocks, but we also actually have to move time here. So the minimum delay is looking for some time. So let's create a new util called move time. Okay, move time.ts. And this util is going to allow us to move time. So you're learning all the cool stuff. So we'll quickly write a script to do this. Import network from hardhat, export async function move time. How much time will be a number amount. Console.log, moving time, and we'll say await network.provider.send EVM increase time, and then just by the amount. Then we'll just say console.log, moved forward amount seconds. It goes forward in seconds. Cool. So now we have this move time function. That was pretty quick, right? So first we're going to move time, and we're going to move time by that min delay first, +1, just to be safe. And then we're also going to move blocks. So we're going to do await move time, and then await move blocks, and we'll just move one block. So we got to import move blocks from utils. We got to import move time from those utils as well. Move time. And then we also have to import this min delay, which we get from our helper hardhat config. Great. So we moved all that stuff. Again, if this were a real chain, you just have to wait. But since we're not a real chain, we can do whatever we want. Yes, love doing whatever I want. Now that it's all queued up, the vote is passed. We're looking spicy. Let's drive this home. Executing. We'll do a little console.log executing. We'll do const execute tx equals await governor.execute. We're going to pass this the exact same set of things we did for the qtx. So I'm literally going to copy this, paste it down here. And then we're just going to do await execute.tx.wait. We're going to wait one block. And then the final hour, we'll see if the governance updated our box contract. Const box new value equals await box.retrieve. And then we'll do console.log new box value. Box new value.toString. Woo! So if we did this right, this new box value should be updated. Let's see if we did it right. Yarn, hardhat, run, grips, queue and execute, network localhost. Did we do it right? Have we successfully done governance? We didn't. That's okay. We're going to figure out what we did wrong. Did you mean Kachak 256? I spelt some stuff wrong. It needs to be spelled like no CK, just K. Okay, let's try again. It failed before it actually did anything. That's good. Queuing, moving time, provider, EVM increase. Oh, because I spelt increase time wrong. Oh no. EVM increase time. Let me just double check. Make sure I'm spelling this right. T is actually capital. So I totally messed up. So it's actually already been queued. It's been queued right now on our little node, EVM increase team. So we could either delete and kind of restart, or I could just go ahead and I'm just going to comment out a bunch of stuff. We're just going to skip the queuing here. We're going to run this one more time because it's already been queued, and now it should just execute. Oh, we're going to move time again, but that's fine. Oh my goodness, we did it. Right, and then normally you would just do it in one script, but this queue would fail because it was already queued, right? You can't queue twice. We'll move forward in time, we moved blocks, we executed, and we got a new box value. Completely using our DAO, completely decentralized voting, completely on-chain, no third-party trust going in on here. There's no voting booth. There's no, spending thousands of dollars on staff. Everything we just voted on happened right in front of our faces. Now, again, highly recommend go to my GitHub repo, you take a look and you see what's going on here. Again, if you want to see JavaScript stuff, feel free to do some JavaScript stuff. But this goes over how to just git clone and get started if you want to do that as well. But if you walked with me here, if you walked through this with me, you have learned an absolute ton. Thank you so much for being here, and I'll see you next time.
Now you are more knowledgeable, you can go out and you can build your own DAO using an ERC20 token as a voting standard. Be sure to smash the like button and subscribe so we can keep giving you the best smart contract coding tutorials on the planet. See you next time.